I understand we're on. Good morning, everyone. My name is Dionysia Triantafilopoulou. I'm a researcher in the Chemnitz University of Technology, and I would like to welcome you all to this webinar about on problem-based learning for cross-sectorial education in the 5G era. This is a webinar organized by the European 5G Digits project. We are going to give you a brief overview of the 5G Digits project, introducing very briefly its purpose, its partners, and its main focus. And then we will move to the main topics of this webinar by firstly introducing to you the work that has been done on this project on the joint curriculum development, and then by going through the process of creating problem-based learning case studies in this for higher education institutions in this project. Then we are going to present the 7 different case studies that we have implemented in this project, and we will finally allow some short time for Q&A and kindly ask you for your feedback, which is absolutely necessary for us in order to make sure that we can optimize our project findings and operations. I will start by presenting an overview of the project on behalf of the project coordinator. The project coordinator is involved, a Greek partner. Unfortunately, a representative of involved, Irini Papadopoulou, who kindly prepared this presentation, was not available today, but I will introduce it to you. It's going to be a brief presentation where we are going to introduce the main focus and aim of the project. We are going to talk about the consortium and then the key aspects and the main objectives of this European project. So in this project, we employ the collaboration and knowledge sharing between higher education institutions, vocational education and training providers, and industry partners in order to foster innovation and entrepreneurship. Our main aim is to make sure that in this rapidly changing and developing 5G world and beyond 5G world now, we want to build a skilled workforce that will have the ability to drive the digital and green transition in Europe, and make sure that this workforce has the full capability to take advantage of the 5G technologies and towards sustainable development. The project budget is around 1.7 million euros. It is co-funded by the European Union under an Erasmus lump sum action. It has a duration of 3 years. We are now approaching the end of the first year.
Nej, man får ju, men jag kan skicka alltså man får ju bara någon när man ska skapa något konto på den här.
Ja, men jag hittar ju aldrig något. Det finns ju
har du till och med skapat ett
And our consortium consists of 12 partners from 8 European countries. We have involved the University of Athens, Infolysis and CNC Solutions from Greece. We have the University of Valencia and Inertia from Spain. We have Karlstad University from Sweden, Chemnitz University of Technology from Germany, Finova from Belgium, Accelerate from Malta, Tekin from Lithuania, and F6S from Ireland. Regarding the main aspects of this project, first of all, we understand and identify that the rapid evolution of 5G technologies have resulted or may result in a gap in the workforce skills. So the aim of this project is to create innovative and teaching and learning approaches in order to make sure that this gap is addressed and that the workforce has the ability to have the necessary entrepreneurial skills in order to address all the issues that come from these advanced 5G technologies. We pay specific attention on the collaboration. We do understand that different types of stakeholders offer different capabilities. So we do have the collaboration between higher education institutions. We have industrial partners. We have vocational education partners. So we promote collaborative initiatives, cross-border certifications, and networking events to facilitate the sharing of best practices and make sure that for this to result in long-term partnerships. One of the main focus of this project is sustainability, which is in alignment with the European Union goals. So we try to integrate digital skills, green practices, and sustainable development principles in the curricula we develop. And we focus on energy efficiency, sustainability, and green technologies for post-5G innovation. Finally, we pay special attention on entrepreneurship and innovation. And we take care of student entrepreneurs by developing accelerator programs and training regarding entrepreneurial skills. So the three main objectives of this project are, first of all, on the development of courses related to advanced 5G technologies, IoT, Industry 4, and AI. We consider that these digital skills are essential for professionals. So we make sure that the curricula we develop cover all these major topics in order for them to be useful and up to date. As mentioned before, we do focus on green skills. We highlight and promote sustainability and environmental awareness. We are going to see this also in today's presentations. The case studies that we are going to present focus mainly on these aspects because they are quite important. And we also develop resilient skills. We focus on adaptability, problem solving, entrepreneurship that are critical skills for professionals who need to thrive in this dynamic and rapidly changing environment of today. This is also fostered through the accelerator programs, the entrepreneurship courses, and we try to support student-led startups in advanced 5G and green technology sectors. This concludes this brief presentation of the project. We kindly invite you to follow us on the different social media and also subscribe to our newsletter on the website. And for any further information, we are more than happy to answer any questions. Thank you. So as a next step to our agenda is a presentation of the joint curriculum development in 5G digits, and this will be presented by Benjamin Molina from the University of Valencia.
Okay, thank you, Dionysia. Thank you everyone for attending this webinar. First of all, I will start sharing my screen in order to be able to perform the presentation. I guess you are able to see the screen, to hear me well. So, okay, we in this webinar are following a top-down approach. So we have started by presenting the main features, the main overview of the project. Now we come a little bit in detail with the working package that supports this PBL approach. In this way, this is work package 2, and I'm the leader here for that during this 5G digits project. What we will see is just a high-level overview of work package 2, and just also a short description of each of the tasks that support.
Benjamin, sorry, may I interrupt? We do not see your screen. We only see you.
Sorry. Let me check again.
Now we can see your presentation.
Now?
Thank you. Yes.
Okay. Sorry again. Let's quick start again. I'm going to present work package 2, which is the work package that supports what we want to present in this webinar. In this work package consists of different tasks, and I will provide a sort of review of each of one. And in this webinar, we will mostly focus on one of these 4 tasks. So let's start in order not to consume too much time. As for the project, just to get the general picture, if you are familiar with the projects at least in the European Union, it consists of several work packages. One of them is dedicated to project management, another for dissemination and exploitation, and there are other work packages related to technical stuff. And this is, for example, the one that we are showcasing this time, which is work package 2, related to the joint curriculum development in order to develop a list of different courses that we want to impact to the European Union according to the objectives that have been previously presented by Dionysia. So in terms of tasks that are conducted by these work packages, we have 4 main tasks. The 3rd task is the one that we will focus today, but in this short presentation, I want just to showcase very briefly these 4 tasks. The first one is related to making a good analysis of what is the current status of the needs assessment in terms of skills requirement. The second one is obviously develop this curriculum. Third one is to adapt this curriculum also to implement the real problem-based teaching approach that relates directly to the resilient skills that was previously commented by Dionysia. And finally, obviously, we need to test the curriculum and to refine the curriculum in order to adapt it and to provide the best curriculum we are able to do throughout this project. So in terms of the first task related to the needs assessments, just 2 small slides related to the process. We identified 4 main stakeholders to which we wanted to engage them. We had the participation of all partners within the consortium in order to target all 4 different profiles. And with them, we approached them and we launched both structured and semi-structured questionnaires and interviews. For the questionnaires, we were able to engage a little bit more than 200 questionnaires. And in terms of interviews, we have a little bit more of 20. This approach of targeting both quantitative and qualitative means provided us the way of making these comparative views in order to focus in different aspects, both, for example, comparing what was the view, the perspective inside and outside the academia, and obviously try to identify which were the required skills for each of the 4 different profiles. The main goal, obviously, as you might imagine, is to have a solid evidence in order to later build the joint curriculum. So as for the key findings and results, just to go to the end, as you can see at the very bottom, the report is public. It relates to a deliverable, D2.1, which is public, and it's quite long. So you have all the information there. There was also a webinar which is available in our YouTube channel. So if you are interested, you can check that. But here, just a very brief summary of what we got from this task. As from the educators, they face it, in fact, various difficulties trying to keep pace with this fast 5G or beyond 5G evolution. As for the students, they wanted they demanded more internships, applied projects, and also obviously access to real 5G test beds. As for the industry, they requested more intertwined knowledge related about AI, IoT, and sustainability. So they wanted more interdisciplinary integration across these areas. And as for the policymakers, they highlighted as many times in various areas this need for funding, for more infrastructure, and also a stronger public-private partnership. So as for the curriculum, just a quick overview here, we just offered 8 different courses from different areas. As you might see, they not only cover technical aspects, technical domains, but also other cross domains like sustainability, energy efficiency, green skills, digital skills, and somehow embedded here also these resilient skills, also entrepreneurial skills. So we think we cover a quite wide range of domains. But in order to be successful, obviously, at the very beginning, you can see that we needed to develop a curriculum development team, which was led by the CDT task force, responsible for designing and implementing it with 21 persons here, and also an external CDT advisory board who was in charge of reviewing this curriculum in 2 different iterations. So in terms of ECTS, if you are familiar with universities and higher education institutions, each of the course was assigned to ECTS, which relates here 60 hours. And this was structured as 20 hours by lectures, 15 hours for practical exercises, and 25 hours of guided independent study. As for the learning objectives, obviously, this is something course specific. And as for the methodology we use here is called the KSA framework. Probably you might be familiar with that. The knowledge relates to the main concepts, to the theory. In most of the cases, skills relate to the practical abilities, whereas abilities refer to a wider concept, which is able to combine knowledge and skills. This approach is quite used in companies and also for certification programs, and allowed us to quite fast identify those knowledge, skills, and abilities that were relevant and priority for each of the courses. So just to provide you a quick overview of how this works with one single example, taking one of the 8 courses, just take one course. Let's suppose the course obviously is divided into modules. For each of the modules, we identified learning objectives. And for this module, we identify from all the list of HEI items related to the course to identify which ones were related, directly assigned or mapped with this module. Obviously, this work was further continued in terms of splitting the module into units, assigning learning hours, assigning also identifying learning outcomes by each of the units, teaching methods, assessment methods, and prerequisites, if any. So by the end, what was the result? The result is that we were able to provide a syllabus for each of the 8 courses. So we have 8 syllabi, and the structure is the one that you might see here quite well. It might seem quite familiar to you if you are adapted or familiar to building this sort of curriculum: general info, course description, detailed learning objectives, not only for the instructor, but for students, detailed modules and units, learning and teaching methods, work-based learning, digital competencies, assessment and feedback mechanisms, and some other related stuff for recommended readings, development of soft skills, industry collaboration, etc. If you are interested on the curriculum for each of these 8 courses, again, we have already submitted, released a public deliverable where you can find all this information. It's also quite long, so I cannot tell anything a lot about it, and just invite you to contact us in order to get more information in or on any of the courses that has been developed up to now. So as for the third task, which will be further developed within this webinar, it was the idea. The idea here was just to, once we have the courses and the material, we need to somehow link it with real-world scenarios. Otherwise, it might be considered as pure theory, and it's not what we wanted. It's not what the EU wants with the courses that we want to develop, not just in this course, but in this project, but in others. For that, we built this PBL approach. We ended up with 7 case studies. I'm going to go into detail because this will be further developed by Giuseppe and then by Dionysia. This PBL approach was developed jointly with the industry, with the VET, and also with higher education partners within the consortium. And here we also wanted to enable this work integrated learning, include some sort of living lab projects, and also try to foster some cross-faculty collaboration. So finally, the last task was about implementing the pilot of these courses and through these different case studies, and somehow try to evaluate both the quality, the relevance, and the employability impact that each of these courses brings here. We also need students, educators, and industry partners to engage to this course and collect the feedback from them, identify the improvements, and refine our curriculums, and as well as the teaching methods we might be using and might be improvable. And finally, obviously, ensure that we are aligned with the EU skills agenda. So in case you want to start thinking, just try to check what is more important to you. In case you wanted to evaluate one of these courses, the quality, the relevance, the employability, the innovation, or the inclusivity aspect. And finally, just some key takeaways before passing the floor to the next presenter. This work package 2 is built as a needs-driven, modular, and multidisciplinary curriculum. I think I was able to show you that in the previous 10 minutes when I started. It is strongly aligned with industry, higher education, and also policy priorities. The idea here is to integrate this PBL learning approach, also incorporating real-world case studies, as will be further developed by my next colleague and presenter. What is coming now is the testing and evaluation. So we will need as much as possible your feedback related to all this curriculum and this PBL approach. And the main idea, the main goal is to contribute further to the EU skills agenda, both covering the digital, the green, and the employability skills. So that's all from my side. I hope you have got a good idea of this work package 2. And now I will start sharing and pass the floor to the next presenter in case I have taken too much time for presenting all of this stuff. Thank you again to everyone.
Thank you very much, Benjamin, for this presentation. It is now the turn of Giuseppe Caso from Carcel University to present the PBL methodology that was employed in this project in order to result in these developed case studies. So, Giuseppe, when you're ready.
I am now. Thank you very much, Dionysia. And I hope you can see my screen already.
Yes.
Perfect. Okay. So thank you and Benjamin for the introduction. So in my slot, I will try to explain the process that we have taken in the 5G Digit project in order to basically create the case studies, which will be described more in detail by Dionysia in the last part of the seminar. So I want to talk a bit about how we integrated the problem-based learning in our project. So this is already something that Benjamin provided an introduction on. So in our work package 2, we started with an assessment, and then this assessment was very helpful for us in order to initiate the actual work in the development of the curriculum. So in task 2.2, we started with developing the 5G Digit courses, the 8 courses that Benjamin provided an overview for. And then we have the task 2.3, where the idea was to develop problem-based learning material, which is the focus for today's webinar, and basically the development of our 7 case studies. At the end, what we had was a parallel development of these 2 approaches. One, I would say, more traditional educational or learning material, and on the other side, the development of the problem-based learning case studies. And as already mentioned before, basically our goal will be to create an integrated curriculum that will be tested and refined in the last part of our project in task 2.4, where we will have the chance to test our material and refine depending on the feedback that we will receive. So today's webinar is specifically focused on problem-based learning. So I'm sure most of you already know what is PBL, but I'm just trying to provide an overview on this methodology and why we believe in 5G Digit is very important in our objectives in the project goals. So PBL, or problem-based learning, is a methodology that basically places students at the center of the learning process by engaging the class into real-world problem scenarios, which we also call case studies in 5G Digits. So PBL basically develops domain-specific knowledge. It also helps improve critical thinking and problem-solving skills. It is very important in terms of improving and helping students enhance their skills in terms of collaboration and communication. And in general, it is proved by many different research papers that the adoption of problem-based learning help in improving lifelong learning habits. So students are basically trained in order to develop over time new skills and new content. I report here just a screenshot from two papers that I found quite interesting, where it is proved by user case studies that specifically for domains that are in the area of 5G digits. So I'm thinking about computer science, telecommunication, engineering. Problem-based learning is very valuable, and it is proved to increase the learning outcome from the students. And in general, what we can say about PBL is that if it is efficiently integrated with the more traditional learning settings, this combo between PBL and traditional learning help in higher motivation from the students and in general deeper learning. And this is specifically true in our domain, or in the domain that 5G digits is targeting. But what is the 5G digital ambition? Right now, probably you already have an idea on this, but just to kind of try to summarize on a high level, what we want to do is to prepare learners for lifelong learning and successful entry into or progression within the job market. So we want to train students that are able to succeed in a very complex and dynamic ecosystem, which is the ecosystem around new digital technologies, and in particular new communication technologies like 5G and beyond 5G system. So what we can say, if we want to achieve this ambition, we believe that a learner-centered educational approach is very important, specifically in the context of rapidly evolving technology. And we know how fast 5G technologies or mobile cellular system technology are evolving. We are already talking about 6G in the research ecosystem. So we need some tool for the training and the educational aspect that are progressing as fast, at least as fast as the topic is progressing. So combined with the traditional learning, as I already said before, PBL offer, in our opinion, a framework to support the 5G digits ambition, because we want via this framework to mirror multidisciplinary problems that students, when they become professionals in a specific job, they may easily encounter in their work environment. So we want to train also on some aspect that students may encounter often in their real job. So in general, with PBL, or better with the combination between PBL and the traditional learning, students learn to identify knowledge gaps, for example, if they have any. They are able to improve their skill in locating reliable information. And we also know how it is important today to be able to discriminate between many sources of information coming from different sources. So, and this is becoming more and more important in the AI era. And they should also be able to test solutions and adapt to possible feedback that they receive during their educational journey, but also during their on the work in their work positions. So in general, what students achieve by combining PBL and traditional learning is to develop these famous, I would say, 21st century skills. And I'm reporting here data from the World Economic Forum, where basically they have identified different skills that students should improve in order to succeed in the 21st century work ecosystem. So when it maps to more practically, it comes to how we map 5G digits with the PBL. I'm just reporting here a couple of examples that helps further identifying why we believe this is basically a perfect match. So on one side, one important 5G digits objective is for students to be able to understand a very complex system, which is the 5G system and the beyond 5G system. And we believe that in this area, PBL clearly supports deep understanding, because it puts the students in the center of the of the case study, and 5G in these case studies, as it will be presented later, is basically taken or considered as a technological paradigm shift. So by placing the student at the center of the educational setting, we believe that PBL can really help into for students to understand better the 5G system, and also in the second point, to acquire more knowledge on the full architecture, on the end-to-end architecture, and on the protocols that are existing in this architecture, which we know are many and are spanning different system layers. Also in this case, we believe that problem-based learning can actually push learners to engage with a system level problem that allows them to look at the 5G system as a end-to-end architecture where different aspects should be taken into account and should coexist in order to find a near optimal solution if possible. So on top of this architecture, students are required to increase their decision-making skills, and also to have a deeper critical thinking about what solutions and what protocol they need to take into account in order to succeed in the proposal of a solution for the case studies. So in general, we also believe that as an objective, it is very important for students to understand the role of 5G and other scenarios. Think about Internet of Things and smart cities service and application. And as we know, all these scenarios are somehow intertwined. So it is very important that the student understand the interworking or interconnection between this scenario, and PBL facing a problem-based learning case study can really help students to understand the dynamics in a higher level. So basically, when different systems are needed to coexist and to perform efficiently a specific task. When it goes more into the, let's say, innovation and entrepreneurial skills, clearly this is a perfect combo with problem-based learning. Entrepreneurial learning is basically one main feature for problem-based learning, because learners are, again, placed in a decision-oriented context where they need to take decision on specific solution. They need to collaborate and communicate efficiently these decisions. So this really PBL really stressed out the need for increasing innovation and entrepreneurial skill, as well as digital and analytical skill, which are very often correlated one to another. And in particular, in this context, PBL also allows to explore different tools that we know they exist in a very large ecosystem, as we are facing here, where students are basically more or less, I would say, free to decide the tool to use, apart from by guiding them into with clearly some initial suggestion, but this freedom of deciding the tool to use in order to solve a problem basically enhance the proficiency that students can achieve in knowing maybe also very complex and very different tools. So again, PBL is a very powerful environment where students can really be put at the center of the educational setting. And just to conclude also in terms of professional and managerial skills, students that face a PBL case study need to be very open and collaborative. They have to cultivate communication, leadership, and they also need to probably face conflicts, and they need to understand how to resolve those conflicts. And also they need to be able into managing time, which is also a very important aspect in their educational scenarios. So these are the main mapping or the main correlation that we found between what we want to achieve in the 5G digit context with respect to what PBL methodology helps and supports us to achieve. So what we did in our task, basically we want to, our goal was to embed the problem-based learning methodology in the curriculum, as we said now many times, and our result is the definition of the problem-based learning case studies. How we achieve this result? Basically by performing different steps. We started with the definition of a competence framework, and then we identified the case study scenarios. Finally, we map these scenarios into the 5G digits courses, and I will provide a bit more detail on this mapping. And then at the end, we needed to actually develop the case study. So we defined a template that the entire consortium used for develop the case study that we identified in the previous steps on top of the 5G digit courses. So with respect to the competence framework, basically here we were facilitated, I would say, in our activity, in our goal, by the fact that the previous task, the needs assessment and the definition of the 5G digit courses started a bit earlier with respect to the development of the case studies. So we basically already had a competence framework, which is the one that Benjamin already discussed, where we were able to create courses, and on top of the courses, we were able to divide these courses in different modules and map different modules into learning objective, knowledge, skills, and ability items, the KSA framework. So basically, we had already an architecture where our goal, and we had already a competence framework where our goal as developers for the PBL material was basically to integrate our work in a already existing framework. And this clearly facilitated our work at the beginning, and it also helped in the alignment and creating case studies that are well aligned and coherent with respect to the 5G digit courses. So with respect to the competence framework, we basically reused the infrastructure that we were using in the development of the 5G digits courses. Then we went to the second step, where the idea was to identify relevant scenarios, and this was also something that we worked a lot on in order to again perform a reasonably good alignment with the development of the courses. As Benjamin already anticipated, we leverage the broad skill set that we have in the project, in the consortium, where we have the higher education institutions, we have the BET educators, also we have industrial partners. So basically what we did in this phase was to create cross-domain teams, and this team composed by different partners. On one side, we have the educators, which contributed the pedagogical perspective, ensuring that scenarios that we want to identify can meet learning outcome, knowledge, skill, and ability items, and also are engaging for the students. So on one side, we have the educators. On the other side, we had the industry that brings industrial competence in terms of existing technical limitation, regulatory constraint, and market priorities. So altogether, we created teams, and these teams were basically working in the identification of case study scenarios in order to balance out an existing trade-off, I would say, which is a trade-off between complexity and feasibility. We also wanted a scenario which, by definition of by following the problem-based learning methodology, has to be open-ended and has to have the opportunity to have multiple solution paths. We don't want students to solve an exercise with a single solution, correct solution. Here we are talking about a case study where different teams, different students may end up with different reasonable solutions. And then we wanted to embed in the case study scenario human-centered narratives where, for example, we want to also embed situations that the students may need to face where we have different stakeholders' demands and they need to work in this trade-off in order to make all the stakeholders happy, basically. So the 5G Digits courses were also developed by a multidisciplinary cross-domain team. So the teams that were developing the 5G Digit courses were also appointed for developing the case study scenarios. So we have a perfect, or I would say an optimal alignment between the development of courses and the development of case studies. Then we went into the third step, which is the integration. Clearly, when we have separate teams working independently, what it can happen is that these teams end up with similar scenarios or with similar, with identifying project that may be too similar or they may be easily integrated. So what we did in order to minimize the application of work and still ensuring a coherent integration was to come together, all the teams from different scenarios. We created the cross-team collaboration opportunity so that teams may talk each other and basically if they identify similar things they are working on, we ended up into integrated the work in order to avoid application again, in order to keep a consistent development within the team and across teams. So at the end, we end up in these phases where we integrated our work in a higher layer. And in this phase, we also started to quantify, so how big this case study should be and what kind of workload we should ensure for this case study. And as you will see later in the last part of this webinar where Dionisa will present the case studies, our case studies, the 5G Digits case studies are formed by at least 24 hours, 24 learning hours, split across lecture, exercise, and independent study time. And these 24 hours basically come from the fact that we want to ensure at least that a case study can cover at least 40% of the total learning experience of a 5G Digit course, which, as Benjamin explained, is 2 ECTS, which is around 60 hours. So 24 hours basically was the perfect number for us to cover 40% of the learning experience of a 5G Digits course. One thing I wanted to stress out, and I will also take this in the next slide, is that the case studies, as you will see, are very flexible, very modular. At the end, what we achieve is that we fully integrated the case studies in the 5G Digits courses. But another main advantage and an opportunity also for you as an audience today is to know that our case studies are also, as I said, modular and flexible, and at the moment can be easily reused outside the 5G Digits courses. So as you will see later, these case studies may be taken by you as an educator in your own institution. And if you want to basically include this case study in your own course related to, for example, 5G or beyond 5G technology and system, you are basically able to do that. Maybe it needs some, alignment, internal alignment, but the case studies, as I see, as we achieved in 5G digits, are fully it's possible to integrate them into a existing course in your own university, in your own educational curriculum. Then we needed to develop the case study. We have identified the scenario. We have identified the main things that we wanted to cover. What we did is, again, to create a common framework for all the teams to work in the same framework. And we achieved this by creating a template for the definition of the case study, which we also release as open source. So you can also use the template in order to create your own case study if you like, where, as you see in this slide, basically the template is formed by different sections. There is a general information table where you need to basically identify the case study on a high level. And then there is an introduction where you need to identify stakeholders and trade-off and challenges that the students are going to face by solving the case study. Then there is a description of the a sort of related work in the context of the case study. Finally, you have the main section of the template, which is the learning or training tasks, where basically here what we have done is to divide the case study into different tasks, and we provide in each table, as you see here in the bottom right of the slide. Each task is self-contained and provides specific description for the students to basically face the task, and you have different steps in the task, and you have an expected outcome, for example, a report or architectural design for the students to solve basically the task and move on the next task. So each case study is divided into self-contained tasks. And then at the end, in the template, we also provide suggested resources and material, and we provide a mapping between the case study learning outcomes and the 5G digits, the courses, which is in the context of the 5G digits, to really important to identify how the case study map into different courses. So just to give the floor to Dionisia, where she will present the case study in more detail. At the end, we achieved the identification of these 7 case studies. Case study 1 is on designing 5G infrastructure for smart city. Case study 2 is to identify key performance indicator and key value indicator in beyond 5G application with a specific target on e-health education. Then we have a third case study where we want students to address the problem of designing and evaluating a sustainable strategy for 5G network deployment in rural and urban areas. Then we have the case study 4, where we want students to leverage and acquire digital skill for network management, again in the smart city scenario. And then we have the 3 case study on the bottom of this slide that cover more innovation and entrepreneurial skill, I would say. So the 4 case study on top are more on the technical side, while the 3 case study in the bottom are more on innovation and entrepreneurship. So there is case study 5, where the students are required to optimize urban mobility with by presenting a solution in the context of minimum viable product. Then case study 6 that cover a strategic intellectual property and tech transfer by placing the student in the context of a 5G startup. And then we have case study 7 where students are required to provide a solution for agri-tech, for advancing agricultural ecosystem by using 5G and using this design-driven innovation framework. And this case study, as I just report here as a summary, are completely fully embedded into the courses. So in this slide, you see to which course, to which 5G digit course the case study belongs to. And if you want to know more information about all of them As for the previous part of the presentation, we have already published a deliverable 2.3, where all the case studies and all the material related to our task of integrating PBL in 5G digital has been published and released. And you may have a look for more detail on our activities and also on the future work that we plan to do. This concludes my part of the presentation. I think I've been a bit longer than what I was planning, but I give it back the floor to Dionisia for the description of the case study. Thank you very much all for listening in.
Thank you very much, Giuseppe, with a very informative presentation. So I will start presenting. Just let me know if you can see my screen.
Dionisia, we see the presenter mode.
Okay, let me then. How about now?
Perfect now, thank you.
Okay, great. So as Giuseppe said, the main focus of my presentation will be the introduction and summary of the main concepts of the 7 case studies that were developed within this PBL activity in the 5G Digits project. So an outline of this presentation, I will briefly introduce the case studies, pretty much summarizing also what Giuseppe and Benjamin described before. And the main body of this presentation will focus on the case studies themselves. We are going to provide for each of these case studies an overview of their main objectives, their focus areas, the roles of the students, and their context. We are going to describe the main stakeholders involved in each of them and to discuss the respective challenges in their implementation. We are going to also present the different tasks and learning hours of these of each case study. You're going to see that depending on the nature of the case studies, there is a variability on both the number of tasks and their respective duration. So we don't have a let's say unified approach because everything is case study specific. And then we're going to discuss specific usage guidelines for the educators in order to implement these case studies. But I will have to repeat something that also Giuseppe highlighted, is that everything was developed with having modularity in mind. So whatever we discuss here in terms of guidelines and assessment criteria is indicative, and educators who are interested in implementing these case studies have the freedom to extract parts that are particularly interesting to them. They are not obliged to use them as a whole. This is not how these were created. So giving the educators a degree of freedom in how to use this material. We are going to discuss briefly the learning hours of these case studies, and then we're going to conclude. But as an appendix, we are also providing, not in the context of something to be presented today, but also as a material that needs to be in one place for the educators, information on how these case studies link to the different courses that were developed in from this project, extensive information on related reading material, and information on how these how each case study is linked to the knowledge, skills, and abilities concept. So we, as also Giuseppe described, we are going to present 7 case studies, generally focusing on 5G and beyond 5G, on IoT, AI, and ML, but of course also more wider concepts. Roughly, they account for approximately 40% of the learning hours of a course developed by this project. And these case studies target both higher education institutions, which are the target of this of today's webinar, and VET professionals. The aim of this is to build a bridge between the theory of the courses and the actual practice. So we are trying to provide the students the necessary skills to actually implement what they are taught in the different courses. And these case studies cover all types of perspectives, including technical, societal, and entrepreneurial. We have a full alignment of with the 8 modular courses of 5G digits, and this is also included. Specific alignment is included per case study in the appendix. And we, as I said before, we provide a full overview of each use case, discussing how it is related to the real world and its challenges, especially under the umbrella of 5G and beyond 5G. We provide an extensive list of resources and materials for further reading, both for the educators as well as the students. We described usage guidelines that can be very generic, but they can also be task specific. And we also do exact direct mapping to courses and knowledge, skills, and abilities. So without delaying, we start with our first case study on the design of 5G infrastructure for smart cities. So we consider a sustainable mobility use case. And this case study focuses on the application of 5G networks in urban mobility and smart city infrastructures. Students are facing the challenge to design a 5G-based solution for real-time traffic management, aiming at sustainability and public safety in a medium-sized city. They need to assess the different trade-offs between performance optimization and energy consumption, and explore the access to digital infrastructure, and they need to propose strategies for a resilient network design. So we go one step further from pure engineering, but also students are requested to be also aware of the societal responsibilities of such an advanced technological deployment. So they are tasked to propose a 5G network design that addresses 3 main goals: smart traffic systems for traffic control, emergency response coordination with which requires extremely low latencies from the network side, and environmental monitoring with the use of large-scale sensors for monitoring of air quality, noise levels, and emissions. The main stakeholders in this case study include the City Transportation Department, which acts as the primary decision maker and coordinator in terms of infrastructure deployment. The emergency services, which depend on very low latencies in order to perform all types of coordination and response in time-critical situations. The actual citizens of the smart city, which are the end users who are the ones that are benefited from the system. The mobile network operators who own and operate the physical and virtual network infrastructure, and they are the ones who are responsible to provide the connectivity. And the technology vendors who supply the network components as well as all type of equipment that is necessary for the realization of this of such an infrastructure. Of course, there are specific challenges when it comes to implementing such a case study. First of all, we have to face the management of the LLC services, because emergency services require extremely low latency, and this needs to be achieved through appropriate network slicing under congestion. The integration of the existing legacy systems with the modern infrastructures that are necessary in order to realize and address all the challenges of sustainable and modern 5G infrastructure. The need to ensure security and privacy of transmitted data. We are living in an environment where massive data which is sensitive, includes mobility information, includes emergency. So there is a need for strong encryption, compliance with GDPR. So then there's the need to ensure legal and secure operations. Of course, anything that is implemented needs to be guaranteeing any SLAs through the network slicing that can guarantee the appropriate quality of service and the necessary adherence to all the agreements that are made. And of course, as we have extensively discussed in this project, keeping in mind that we need to guarantee sustainability and energy efficiency. This case study is considering 3 tasks. We can see that they have an increasing amount of hours allocated per task. The first one includes the analysis of the needs of the smart city. We need to identify the different challenges of the city. These need to be mapped to the 5G features, and then we need to go one step further from typical and narrow-minded network engineering, and we need also to consider the social and environmental factors that needs to be included in any decision-making process. Then, for proceeding to the second task, students will design a logical 5G system. They will integrate technology advancements like massive MIMO, edge computing, network slicing, and any architectural decision will need to be backed by specific performance indicators. Finally, the final task will make sure that the feasibility and the viability of this infrastructure is assessed. So real-world implementation issues will be reviewed, and the scalability and sustainability will be evaluated, and then 6G will be part of the equation in order to consider possible future evolutions. As a guideline for how higher institution educators can use this case study, this is a case study that can be used for group projects. We suggest groups of 2 or 3 students, but tasks can be used either in short workshops or combined as a big project. Specifically for tasks 2 and 3, in task 2, group discussions are highly encouraged because they focus on design thinking, and in order to capture the different perspectives, debates or role-playing are encouraged. And for task 3, when we are discussing about the feasibility, sustainability, and scalability, also towards future trends, we strongly recommend the use of real data sets or smart city case studies in order to enhance the reliability of the whole project. Moving on to the second case study on identifying key performance indicators and key value indicators for beyond 5G use cases. This is under the context of remote and immersive e-health education. And keeping in mind that that the transition from 4G to beyond 5G or even 6G, we need a more human-centric approach. We don't want to focus only on technical enhancements through the KPIs, but we also need to keep always in mind the societal impact. So we need to include the dimension of key value indicators or KVIs. So students are tasked to explore this paradigm shift through the lens of a very important vertical industry, which is the remote and immersive e-health education. So the use case is centered around the design and deployment of remote and immersive e-health education services. The focus is on real-time medical and nursing training enhanced by advanced technologies like virtual reality, augmented reality, extended reality, or haptic feedback. These applications are very demanding in terms of what they need in order to operate properly from the network. So they have very stringent requirements in terms of latency, reliability, security, accessibility, sustainability. So all these requirements will need to be quantified in terms of KPIs and KVIs. The main stakeholders in this use case include the healthcare institutions and the universities, who are the main primary content providers and the main service consumers, who need to train their future personnel with the use of these advanced tools. The telecommunications operators and the infrastructure vendors, who are the ones who need to guarantee that the underlying network infrastructure can support appropriately the demanding requirements of these services. The policymakers and the regulators, who need to shape the frameworks that govern very important aspects related to these technologies, including trustworthiness, safety, sustainability. And finally, we have the technology providers who are the ones who provide all these advanced solutions, the AR, the VR, the haptic solutions, and any medical instrumentation which is necessary for this ecosystem. They provide the devices, the platforms through which the students access all the content for this case study. Of course, there are many challenges in this case study. Primarily is the balance between performance and value in the network design, in the implementation and the evaluation. So students are not only asked to identify technical features that are necessary for the support of this use case, but they also need to assess how these features can be mapped to broader societal goals. For example, when we need to make sure that we offer a service with extremely strict latency requirements, this may not be feasible in more remote areas where the network infrastructure may not be able to allow it. Another challenge is the translation of qualitative societal requirements into more tangible and measurable indicators that can be used in order to perform the network design and the policy derivation. So by the end of this case study, the students will have had the opportunity to develop a comprehensive understanding of how to jointly design architectures and performance and value evaluation frameworks for advanced verticals. This case study has 4 tasks, some with a total duration of 24 hours. I will repeat that again. These are modular and can be used with the discretion of the higher educator institution. First of all is the understanding of the KPI and KVI paradigm in beyond 5G and 6G systems. There is extensive literature in the area from mainly EU projects, so students will have to go through that and understand both the technical as well as the societal dimension of this paradigm and identify the relevant stakeholders and the priorities. Then the second task considers the definition of the requirements of remote and immersive e-health education. So again, the aim of this task is the final extraction of indicators from system demands. Moving on to the third task, which is the identification of the respective architectural solutions for the support of such e-health systems. So we need to map the system features to the KPI and KVIs, understand the concept of the evolution from legacy 4G systems to more modern 5G and beyond 5G systems, and to identify the various gaps or limitations that are met in legacy systems. And then the fourth task on the design of the final design of a KPI and KVI aware 5G and beyond 5G solution. So the result of the previous task will be synthesized into a cohesive system. There will be the collaboration of the students on the design problems and the final communication of the findings. In terms of how this use case, this case study can be implemented. We have, again, the modular structure. We designed tasks 1 to 3, emphasizing on the personal reflection and research of the students for this highly demanding and area. And then when we are moving to task 4, we encourage teamwork and solution synthesis. When all these tasks are used in collaborative settings, we recommend tools such as shared documents, online discussion platforms, collaborative diagrams, and for hybrid learning environment, any lecture content can be delivered through recorded videos or even self-study. Moving to case study 3 on the design and evaluation of sustainable 5G network deployment strategies. The aim of this case study is to address the challenges of a fictional national mobile network operator that is tasked with the deployment of a large-scale 5G strategy. And the aim to align with the European Green Deal and national sustainability objectives. What the students need to do in this case is to explore ways to consider the environmental impact and to make any adaptations necessary without sacrificing the service quality or the cost effectiveness of the proposed solutions. And this case study is aligning with all the EU sustainability targets when it comes to digital and green transition. So this fictional operator needs to craft in less than a year a nationwide plan which needs to be commercially viable and but also needs to meet very strict green targets. So they're facing the challenge in the rural areas where off-grid macro sites where diesel is not acceptable are used, and they need to consider hybrid renewables that need to guarantee uptime. They have the urban areas where dense and small clusters need to be optimized in areas that are characterized by extreme high capacity, like stadiums, rail hubs, but they still need to stay within the CO2 emission budgets. We do have also the concept of life cycle. So the operator needs to demonstrate circular economy compliance. And of course, focus also needs to be paid on the policy and finance. So they need to unlock green bond funding, tax credits, spectrum fees, and all needs to be under the umbrella of sustainability and all the related KPIs. The main stakeholders considered in this use case are the network infrastructure providers, the equipment vendors, who are the ones who bring all of the necessary equipment for the realization of this big project, the national regulatory authorities and public policy makers, who are the ones who dictate the rules under which all this needs to operate, and especially when it comes to CO2 emission mandates and energy budgets. And citizens and non-governmental organizations need also to be listened to. They are expressing their feedback as well. Of course, academic researchers and consultants in sustainability and telecommunications, We have the economic aspect of equipment financing institutions and supply chain partners, and of course, the local governments and municipalities. The main challenges for this use case are identified having to do with energy consumption. There may be limited or unreliable grid power at remote rural sites, but still service needs to be guaranteed. The high capital and operational expenditure of hybrid renewable systems and storage. So yes, CO2 emissions need to be limited. Fossil fuels need to be avoided, but on the other hand, the use of any other type of energy needs to be carefully budgeted due to these related expenses. The integration of circular economy in equipment procurement and vendor contracts. The unfortunate fact of the absence of harmonized metrics for energy intensity and recyclability, the regulatory fragmentation, and the sometimes weak incentives that are given for Greek investments, and the need, finally, to balance network performance and sustainability KPIs when it comes to urban network densification. This case study is a little, in terms of learning hours, it is a little bigger than the previous one. It has a total of 30 learning hours split in 8 tasks, varying from 3 to 4 hours per task. It covers topics including the design of renewable energy solutions for rural 5G towers, the development of green deployment strategies for urban 5G networks, aspects of regulatory compliance and energy auditing, and creation of policy and market incentives for green 5G adoption. Moving on to tasks 5 till 8, there is the need for the evaluation of green ICT principles in network planning, the eco-design principles when it comes to 5G hardware, and the evaluation of the environmental impact of each design choice. A simplified life cycle assessment of the infrastructure, and finally the circular economy strategy for 5G network end of life. Again, especially due to the fact that this is a slightly heavier case study in terms of the recommended workload, instructors have the ability to select only a subset of these tasks depending on the respective curriculum design. So any type of combination is possible. And given the modular nature of this case study and its suitability for online delivery, group work is optional as well. In terms of the evaluation criteria, this case study is designed to be adaptable because we recognize the fact that different instructors may include a subset of the tasks based on their specific course focus or on their time constraints. There are in the respective deliverable, there are some recommendations, but this comes again to the individual instructors and the way they want to implement and incorporate the tasks in their learning, in their individual courses. Moving on to case study number 4 on leveraging digital skills for intelligent 5G network management in smart cities. So this case study considers a national network operator who collaborates with the regional smart city authority to deploy and manage 5G based services that range from remote health monitoring and environmental sensing to autonomous mobility and smart traffic control. This can be considered as part of a national program to demonstrate the intelligence, the security, and the efficiency of 5G services, and how these can be enhanced. It can be used to enhance the public life in urban areas. The students in this case study take the role of digital analysts and engineers who are collaborating, who are working with the national network operator and the municipal authority. And they need to design, secure, and optimize 5G-enabled urban services. This case study reflects the key priorities of the European digital decade and the drive for and the need for trustworthy and sovereign digital infrastructures. So data-driven optimization will be applied to 5G systems. Real-time dashboard for operational insight will be deployed and interpreted. Machine learning and AI models will be built and evaluated for anomaly detection. Cybersecurity and risk analysis will be conducted, and the appropriate countermeasures will also be proposed. And of course, this will be done while ethical and legal considerations will be integrated into the service design. The main stakeholders of this case study include the national and regional telecom operators, of course, the smart city authorities and the urban planners, the providers of the digital services, and the developers of machine learning and AI solutions, and consultants on cybersecurity and data protection, and of course the citizens and end users who will eventually interact with these 5G enabled services. The main challenges come from the need to manage multiple services and the corresponding 5G network slices with guaranteeing the diverse and usually very strict latency bandwidth and availability requirements. This is a purely technical challenge. The need to visualize massive amounts of real-time data in order to offer the necessary real-time insights. The need to use machine learning and AI techniques for the detection of anomalies and, very importantly, of cyber threats. The alignment of the service design with ethical, as we discussed, privacy and security requirements, and the need to report the findings in a format that can be accessible to both technical but also non-technical stakeholders. This case study also has considered in total 30 learning hours. They are divided in 6 tasks of 5 hours learning hours per task. We begin by exploring the digital tools behind the 5G smart services in order to make sure that the students have the opportunity to understand their role and to familiarize with data visualization platforms, because this is one of the major points of this case study. Moving forward to the second task, which needs to design and create the interactive dashboards for real-time monitoring of 5G services and considering also the 5G KPIs to support any decision-making in a smart city. Then in task 3, the use of machine learning for the detection of traffic patterns in 5G networks. This will be used for the identification of network usage profiles and performance anomalies. And very closely connected to task 4, which is the analysis of cybersecurity risks in 5G smart city scenarios, because this is very important when it comes to protection against cyber threats and most importantly, the proposition of the respective mitigation strategies. And a slightly more technical task, the design of a 5G network slicing strategy for such applications in order to make sure that the requirements of such services are appropriately met and guaranteed from the network side. And finally, the use of HEI for anomaly detection and response in 5G networks, with the ultimate goal of designing an incident response workflow for smart city network administrators. Again, when it comes to the usage guidelines, each task includes we have, again, the modular character of these tasks. They can be run either sequentially or by the instructors, or the instructors can select the ones that are more closely linked to their existing modules. And the activities are designed keeping in mind that can be delivered online or in person. And they can switch between individual and team-based formats. Each task includes specific performance expectations. They are related to technical accuracy, analytical depth, ability to communicate complex digital concepts. So the respective assessment methods are indicative, and again, the respective instructors have the freedom to define their assessment methods as they find more appropriate. If we move to case study 5 on optimizing urban mobility with edge-enabled 5G systems, following a minimum viable product approach. The aim of this case study is to use 5G networks jointly with edge computing towards designing smart urban mobility solutions. Specifically, learners apply creative problem solving, and we introduce also the concept of entrepreneurial thinking in this case study for the design of a minimum viable product solution. So students take the role of an entrepreneurial team with the task to design a solution for the use of edge-enabled 5G deployments. The focus is on user needs discovery, value proposition, design, and rapid prototyping. The case study is set in the context of a mid-sized European city that is developing a new digital mobility solution to address growing issues of urban congestion, public transport inefficiencies, and increased environmental concerns. So the city authorities are exploring the ways that 5G and edge computing can be employed in order to improve the way people move through the city and conduct their daily activities. The main focus is on user needs, discovery, value proposition design, and rapid prototyping. Technical complexity is kept at conceptual level because the focus is to allow participants to concentrate on their problem solving, the mapping to different stakeholders, and early stage business model development. The main stakeholders in this case study are the city transport and smart city departments that are the ones that are actually facing the inefficiencies of the current assumed situation. The end users who are using the public means of transportations, the cyclists and the pedestrians who look into improving their daily commute and their daily movement around the city. The local startups and edge network operators and software vendors, as well as the user groups of citizens and city innovation labs. Moving on to the respective challenges, first of all, there is the need for the students who take part in this case study to identify specific user problems that have to do specifically with urban mobility. Then there is the need to propose a simple and testable MVP solution that has the ability to take advantage of the 5G and edge computing capabilities without over-engineering and too much technical complexities. Then there is the need to map early adopters and core stakeholders that are related to this problem and sketch basic user flows and interfaces. The final step of this and the final challenge is the preparation of a short pitch that considers assumptions, metrics, and proposals for next steps. This case study has in total 24 learning hours split in 3 tasks of 8 hours each. So the first task, consider the identification of the urban mobility challenges for 5G edge solutions, and considers the actual real-life problems and the necessary contextual analysis of inefficiencies that are related to traffic, safety, and any type of service provided. The second task considers the design of an MVP solution and the validation from a user-centric point of view. So it needs to describe different elements like latency, data flow, and user privacy, and then apply user feedback techniques to validate this design. Finally, a more less technical but more business task related, the business model and deployment plan, where students are asked to define the value proposition and the business model and prepare eventually a pilot deployment plan that considers key stakeholders and constraints. Similarly to the others, this case study is designed keeping in mind the flexibility to support different formats, either in person or hybrid or online. Educators may choose to deliver all 3 tasks either sequentially or pick the ones that are more appropriate to their course goals and time availability. And tasks can be used for either individual work, team collaborations, or part of wider PBL workshops. In this case, learners are expected to engage in practical, real-world problem solving, to emphasize on the application of entrepreneurial methods and MVP development principles. And for this, again, keeping in mind that the way each educator will consider this may differ, we have defined tentative evaluation criteria, but this can be tailored according to the educator and specific course needs. The sixth case study on having a more legal flavor on the strategic intellectual property and tech transfer in 5G. This case study introduces students to the strategic use of intellectual property in the context of the 5G ecosystem, which is rapidly evolving. Students have the role of an innovation advisory team that needs to support a fictional early stage startup, which is called WaveCore. And this startup is developing edge-enabled 5G base station modules with AI-assisted energy optimization. The task of the students is to design an intellectual property strategy for the support of growth, to also avoid legal risks and create value through licensing or partnerships. This case study is situated in the context of a high-tech startup entering a very competitive 5G telecommunication landscape, and considers concepts like standardization partners, fair, reasonable, and non-discriminatory terms, and cross-border IP dynamics. So the main focus areas include the protection of intellectual property, the concepts of tech transfer and commercialization, considering global risks, different licensing strategies, and of course, and very important, the engagement of the various stakeholders that can be related. The main stakeholders in this case study include the founders and the engineering team of this fictional startup of WaveCore, the tech transfer office of a university, which is the intellectual property co-owner, of course, the major standardization bodies like 3GPP, potential corporate licensors like equipment manufacturers or telecommunication operators, sources of public funding or potential investors at the early stage of this startup, the potential initial customers and end users of any solution that is developed by the company, and of course the competition, emerging competitors when it has to do with indirect stakeholders in shaping the IP strategy. Many challenges in such complicated environment. First of all, the task of selecting the most appropriate pathway for protection of the intellectual property. There may be the choice between patenting and trade secrets, and this may be this will depend on the different elements of innovation. Then the mapping of all the intellectual property related tasks across different regions that include litigation exposure, restriction of exports, and licensing barriers. The evaluation of licensing and tech transfer routes, the simulation of negotiations with multinational operators who are interested in licensing these fictional startups energy optimization algorithm, and the delivery of a short roadmap and risk balancing, technical, legal, and commercial considerations. We have two big tasks for this case study. Each one considers 12 hours of learning, having the 24 in total. First of all is the design of an intellectual property protection and technology transfer strategy. Students will need to understand the different types of intellectual properties which are relevant to the 5G-based startups. They need to compare the different protection strategies that are considered across different areas of the world. We will mainly consider the EU, the States, and East Asia, and the students will need to develop a roadmap linking intellectual property to commercialization goals. Then, in the second task of licensing and intellectual property risk scenario simulation, the students will identify international intellectual property risk factors, will understand key concepts in licensing negotiations, and finally simulate the strategic decision making when it comes to intellectual property disputes. This case study is designed to support flexible delivery across diverse learning environments. So whether it is taught in a classroom, whether it's in a hybrid format or online, it fits well with intellectual property strategy, innovation management, or entrepreneurial modules, and can be conducted through team-based simulations, individual assignments, or as a short course sprint. Tasks, again, I'm repeating myself, are modular and can be delivered sequentially or independently. And the material supports experiential learning through realistic simulations and decision-making scenarios aligned with 5G innovation. And moving to our seventh and final case study, which is in the agricultural domain, on the advancement of precision agriculture through 5G-enabled smart farming. The aim of this case study is to employ the real-time data capabilities of 5G for the development of smart farming solutions that offer new possibilities for the optimization of the different operations, for the reduction of environmental impact and the revitalization of rural economies. Students will take the role of a startup team collaborating with telecom providers, agricultural experts, and equipment manufacturers to develop a minimum viable product that integrates 5G connectivity, edge computing, and IoT sensors. Students will need to engage in co-creation workshops, design sprints, and interviews with stakeholders to validate the user needs and iterate rapidly on smart farming prototypes. This comes from the fact that as European farms face big challenges when it comes to labor shortages, climate variability, economic pressures, precision farming emerges as a key enabler of sustainable and resilient food systems. So the students will need to understand the role of 5G in the transformation of agricultural operations that can include sensor integration, autonomous machines, real-time analytics. They will need to apply design thinking and user research for the co-creation of precision farming solutions. They will need to develop and validate a minimum viable product and business model, which is specific to the agricultural sector. And of course, to explore the challenges of digital adoption in rural ecosystems. So that will also include interoperability, infrastructure gaps, and even behavioral barriers. There are many different stakeholders in this case study as well, from local farmers and agricultural cooperatives, the founding team, which is responsible for all the technological advancements, the telecom infrastructure partner, who is responsible to provide the connectivity and edge capabilities for these smart farming solutions, the agricultural policymakers and the agencies that are responsible for rural development in the European Union, of course, potential investors and equipment providers for agricultural projects, any advocates on sustainability and monitoring groups for environmental issues, and of course, again, the financial aspect of public funders and early stage investors. Many challenges in this domain as well. The need to conduct research to identify what are the main problematic issues in farming and what are the pressing climate-related challenges. The need for the students to design a minimum viable product with clear functionality and value assumptions. The simulation or conducting of actual farmer interviews and co-creation workshops in order to grasp the main concepts and adapt as quickly as possible. The building of a canvas model which is tailored to the actual conditions of a smart agriculture innovation, and the delivery of a stakeholder pitch for the balance of technical feasibility, user desirability, and business viability. Of course, also the identification of any potential barriers against the adoption of these solutions, which may come from connectivity gaps, people's resistance to change, and limited trust in digital tools. This case study has 3 tasks, which sum up to 24 learning hours in total, starting from the understanding of smart farming and mapping a regional context, then the design, thinking, and validation and iteration, which will end up in the visualization of a product functionality and user journey, and the business model and pitching, which will be used to communicate the solution effectively to all the interested partners. Again, this case study is designed to support flexible delivery in diverse formats, either on campus or hybrid or remote, and it fits very well into modules that are focused on digital innovation, agri-tech entrepreneurship, and sustainability transitions or rural development. Learners will go through a realistic simulation where a startup prototypes a 5G-enabled precision agriculture solution in partnership with farmers and telecom stakeholders. A summary of the structure of the learning hours. this is indicative. So most case studies, as we discussed, take 24 hours in total, and this is this corresponds to 40% of a full 5G digits course. We have the exception that we discussed with case studies 3 and 4, which take 30 hours each, but this is not an issue because as we have repeatedly said, they can be used to extend the total course workload in any appropriate manner. And educators have the capability to replace parts of the course, and it's up to the individual educators to integrate the different tasks and components of each case study as they find more appropriate in their respective courses. To conclude, in this project, we have achieved the successful integration of the PBL methodology in the curriculum that is developed by the 5G Digits project. And we designed and described today 7 different PBL case studies that are that their main purpose is to support the 8 courses that were developed and today were described by Benjamin. The case studies serve as a PBL-oriented extension of the overall educational strategy of the 5G Digits project, and we today presented our strategy and provided implementation guidelines. I would like to thank you very much for your attention, and I will very quickly point also to the appendix of this presentation. I understand that this material will be circulated to you. So for each case study, we have included a number of slides through which I will not go now for timing, due to timing constraints, but we provide for each case study a summary of suggested materials for further reading, the detailed mapping to 5G digit courses, and the mapping to the knowledge, skill, and abilities. For example, you can see here we have the suggested materials for case study 1, which are also grouped into the depending on the main topics that they covered. We have the detailed mapping to the course of the specific course of 5G digits that we have developed and the respective modules and units, and the mapping between the knowledge, skills, and abilities. This is also done for all 7 case studies and can be found in this in the remainder of this presentation. So thank you very much once again. This I don't know where does it look like that. Thank you very much for your attendance here. We are looking forward to receiving your questions, and for anyone attending today, you will receive a questionnaire that we would highly appreciate if you could fill in and return to us in order for us to make sure that we incorporate your feedback in our future work.